Good morning, students. So far we have been discussing about the Fourier series between some intervals, like for example minus pi to plus pi or 0 to 2 pi. Now this lecture is going to be devoted on change of length interval. So we are going to change the interval. Say for example minus pi to plus pi to minus L to plus L. So we are going to change the interval. Okay. So change of interval from minus pi to plus pi to minus L to plus L. The interval of Fourier expansion minus pi to plus pi may be changed to general interval minus L to plus L, and we are going to look into some discussion. Let the periodic function have a period of a period 2L. Then we are going to introduce some variables y equals pi x by L. So similarly then x becomes cross multiplying, that will give you Ly by pi. Okay. Now the function f of x, which is the definition for your Fourier function, Fourier series. So f of x is given by this equation. Instead of x, you substitute Ly by pi. I repeat, see here f of x is nothing but your Fourier series. We know already. And instead of x, you just substitute the new variable Ly by y. And we are going to introduce another function psi of y, which is nothing but your f of x, and instead of y you substitute pi x by L here. Instead of y you can substitute pi x by L here. Okay, so we have the Fourier series here. A naught as it is like this, you have an cos ny. Instead of y you have to substitute pi x by L. See here. Now as usual the Fourier coefficients can be defined as a naught equals 1 by 2 pi in the old interval minus pi to plus pi psi of phi, which is nothing but instead of psi of phi, which is nothing but area of Ly by pi, and we are going to change the interval minus pi to plus pi as minus L to plus L. So interval has been changed. See here the interval, the limits have been changed. 1 by 2 pi minus L to plus L f of x d pi x by L, which is equal to pi by L. You pull it out, this pi and this pi will get cancelled, we have 1 by 2L. Okay, your f of x as it is like this dx. So this is your a naught. Okay, see in the old Fourier series we have a naught is given by this, whereas after changing the interval a naught is given by this. Similarly you can go for an and bn, the coefficients for an and bn. Your an is nothing but f of x cos n pi x by L between the interval minus L to plus L, and bn is given by this expression. And of course the sum of this series will be f of x plus 0 plus f of x minus 0 divided by 2, and between minus 1 and plus 1, and this is your sum of the series. Okay, which is the period 2L. Now what is the corollary? Fourier series in the interval 0 to L. So this is for half range series. See here we have minus L to plus L. Now this is for half range series, change of interval for half range series, that is 0 to L. Earlier minus L to plus L, and this is for half range series, this is 0 to L. So in this case for the even function your f of x will be this expression equation 5, and the coefficient a naught is given by this. See here 1 by L, 0 to L, the coefficients. Similarly an equals 2 by L f of x cos n pi x by L dx. And for the odd function, this is for the even function. For the odd function, this is given by this. So your f of x is given by this, and the coefficient for the odd function bn is nothing but for the Fourier coefficient given by equation 9. So now interval from minus pi to plus I, 0 to 2 pi. So this is another 0 to 2L actually. So 0 to 2L. So earlier minus L to plus L, then 0 to L, then now goes from 0 to 2L. So in this case f of x is given by this expression, and your a naught is given by 1 by L, 0 to 2L. See 0 to 2L f of x dx, and a is given as 1 by L, 0 to 2L f of x cos n pi x by L dx, and bn is given by this, and minus L to plus L. Okay, minus L to plus L, again we have already seen, and f of x is given by this, and a naught is given by this. an is 2 by L minus L to plus L f of x cos n pi x by L, and your bn is nothing but 2 by L minus L to plus L f of x sin n pi x by L dx. Okay, so this is for the again 0 to L summary, and this is for your f of x. A naught is given by this expression, a n is given by this expression 0 to L, and similarly, and for the sine series f of x is given by this expression, or bn is given by 0 to L f of x sin n pi x by L dx. So with this introduction about the interval, change of interval, we will try to solve some problems. Find the Fourier series of the function. So within this interval, so t lies between minus 2 and minus 1, 0. T lies between minus 1 and 1, k. T lies between 1 and 2, again 0. So this is exactly resembles with this one. So this is even function. So look at the square wave. This is even function. See, exactly similar to this. So this is even function. Okay, we are going to calculate. See, interval minus 2 to plus 2. See, minus 2 to plus 2, minus 2 to minus 1, minus 2 to minus 1, it is 0, and there exists k here. Again 1 to 2. See, 1 to 2, answer is 0. So this is 0, this is k, this is 0. See, 0, k, 0. So find the Fourier series of the function. So Fourier series is given by this expression. So we know already Fourier series is given by this expression with the change of interval. Okay, with the change of interval. Here the period 2l equal to 4, your 2l equal to 4, so your l equals 2. Okay, and as I said, this is even function. So this is even function. Look at the graph. This is even function. So your even function means bn equal to 0. There exists only two coefficients, a0 and an. Bn will be 0. Okay, there's a mistake here. Bn, there's a mistake here. Somebody can correct this one. Bn sin is missing here. Sin n pi t by L. Sin is missing here. Okay, so bn is 0, of course, because this is even function. There exists only two Fourier coefficients, a0 and an. So just to get the value for a0, get the expression for your an, substitute here, get it for Fourier series f of t. That's all. Okay, so first we will calculate a0. Is it okay? See, your bn is 0 because this is even function. So there exists only a0 and an. We are going to get the expression for a0 and an. So a0 is given by this expression 1 by 2l minus 2 to plus 2, because you look at the interval minus 2 to plus 2, minus 2 to plus 2 f of t dt. So now we can what is 2l? 2l is nothing but your 4, because 2l is here. See here 2l. So 2l is nothing but 4. So instead of 2l you substitute 4 here first. Then we are going to separate the intervals according to the limits given. See, limits are given. See, minus 2 to plus 2, we are going to separate the limits. Minus 2 to minus 1, minus 1 to plus 1, 1 to 2. Is it okay? See here, minus 2 to plus 2 ultimate limits, but we are going to separate the limits. Minus 2 to minus 1, minus 1 to 1, 1 to 2. See, 1 to 2. And what is f of t in this interval? F of t is 0. There exists only k alone in this interval. Here also it is 0. So this must be 0 here, this must be 0 here. There exists only k. Is it okay? So you have 0, 0, k dt. K is constant, you pull it out. And dt integrate, that will give you t. Substitute the lower limit and substitute the upper limit. So upper limit and lower limit. So that will give you 1 minus of minus 1, that will give you 2. So strike it off, that will give you k by 2. So a0 value will be k by 2. So we have found out one Fourier coefficient, a0. The next one is an. An is 1 by L minus 2 to plus 2 f of t cos n pi t by L dt. Now again separate the limits. Minus 2 to minus 1, minus 1 to plus 1, 1 to 2, this will be 0, this also will be 0 according to the problem, and there exists only the center term alone. Second term alone there exists. So we have only center. So instead of f of t, you substitute k, you pull it out. Okay, you pull it out. So that will give me k by 2. See, k by 2 integration of cos n pi by t dt. Cos n pi by dt integration. So that will give me sin n pi t by 2 divided by n pi by 2. Is it okay? Simple integration. Integration of cos n pi t by 2 will give you sin n pi t by 2 divided by n pi by 2. Okay, these two and these two will get cancelled. Suppose it goes to the numerator, that will give us 2k divided by 2nk, 2 will get cancelled. And we have sin n pi t divided by 2 alone, divided by n pi. I have pulled n pi out. Now substitute the upper limit. Upper limit, that will give you sin n pi 1 divided by 2 minus sin n pi minus 1 divided by 2. Sin minus theta. What is the answer? Sin of minus theta. Sin of minus theta, minus sin theta. Okay, so minus plus. Sin of minus theta equals minus sin theta. Cos of minus theta equal to plus cos theta. So sin of minus theta equal to minus sin theta. Minus plus. Okay, minus plus, that will give me 2k divided by n pi sin n pi by 2. So this is the ultimate answer for your an. So we have found out a0 and an. Substitute these values in series. Fourier series. We will have, instead of a0 you substitute k by 2. Instead of an you substitute this expression. This is your Fourier series. Okay. Now we can simplify the Fourier series by substituting for n equal to 1, n equal to 2, n equal to 3, goes on. So you have k by 2 here, the first term. Second time you substitute 1 here first. Okay, we will substitute. So we have 2k by n pi, I have pulled out. Okay, 2k by n, for n I am going to substitute 1, 2, 3, goes on. Okay, we will substitute first 1. Okay, so n equals 1 here. Is it okay? 2k by pi I have pulled out. See, I am going to expand the summation here. I am going to expand it. Substituting n equals 1, 2 and goes on. So instead of n, I am going to substitute 1 here. So 2k by 1. So you have 2k by pi sin pi by 2. Sin pi by 2. Okay. And this term will be cos pi by 2 by 2. Plus, substitute now 2 here. So 2k by, substitute now 2. What will be the answer? Substitute now 2. Substitute now 2. See here, 2. Sin 2n pi. What is sin 2n pi? 2 will get cancelled. Sin n pi, that will become 0. So you have to substitute only 3. Okay, so now 3 becomes 2k by pi I have pulled out. So you have 1 by 3. Okay, we have 1 by 3. So 2k by 3 pi sin, instead of n you are going to substitute 3. So 3 pi by 2 cos 3 pi by 2 by 2. Similarly you can go for 5. So it will work out only for the odd numbers. 1, 3, 5, 7, it will work out. Now k by 2, 2k by pi. Okay, 2k by pi. What is sin pi by 2? Sin 90? 1. So we have cos pi by 2 by 2. Minus. Why it is minus sign? What is sin 3 pi by 2? Sin 270. What is the value of sin 270? Minus 1. So that's why it is minus 1. So minus 1 by 3. Okay, minus, we have already pulled 2k by pi out common. So we have 1 by 3 cos 3 pi t by 2. Similarly, other terms. So this is a required Fourier expansion of given function f of t. Find an even function of f of x if x is defined as. So in this interval, x is defined as kx. In this interval, x is defined as kl minus x. So look at the limits, they are not pi to minus pi to plus pi or 0 to 2 pi. We have changed the interval. Now 0 to L. Okay, we have changed the interval. Now you have to use only the Fourier series for the change of interval. So your f of x is given by this. It is given as even function. So there is no bn here. So it is even function. There is no bn. Bn becomes 0. Bn is 0 for the even function. So there exists only two terms, a0 and an. So a0 is given by this expression 1 by L 0 to L f of x dx, which is equal to 1 by L. Now we can divide the limits 0 to L by 2. So 0 to L by 2, L by 2 to L. Your f of x is given by kx. Your f of x is given by kl minus x. See here, the first term will be kx. The second term will be kl minus x. So we have now I have pulled 1 by L out. Okay. So kx, I can pull k out. So what is the integration of x? X squared by 2. We will have to substitute the upper limit. Upper limit is nothing but your L by 2. L by 2. See here, upper limit is nothing but L by 2. X squared by 2. You will have to substitute L by 2. It becomes L squared by 4. Already 2 is there. So 4 2s are 8. So L squared by 8. Is it okay? I repeat. See here, you have x squared by 2. Instead of x, you have to substitute L by 2. Okay. So L by 2. So x squared becomes L squared by 4. Already 1 2 is in the denominator. So you have L squared by 8. Then next term, substituting the lower element will give you 0 because 0 is there. The next term will be k L minus x. So k integration, that will give you Lx minus x squared by 2. You have to substitute the upper limit and lower limit. Here the limits are L by 2. See, L by 2 to L. So we have to substitute the upper limit. Okay. So substituting the upper limit will give you, here already L is there. So L. I have written LL. Substituting the lower element will give you minus L by 2. So that becomes LL by 2. So L squared, here also you have L squared. Now minus x squared by 2. Substituting the upper limit will give you L. So L squared by 2. So that becomes minus L squared by 2. Okay. Now already when you are going to substitute the lower element, one minus is there. So minus plus. So plus. Substituting the lower element will give you L squared by 4. Already 2 exists. So L squared by 8. So we have L squared minus L squared by 2 minus L squared by 2 plus L squared by 8. Taking the LCM. Just take the LCM will give you 8L squared minus 4L squared minus 4L squared divided by L squared by 8. 4L squared minus 4L squared minus 8L squared. This one will get cancelled. So you have L squared by 8. So KL squared by 8. KL squared by 8 plus KL squared by 8, that will give you 2KL squared by 8. 2 divided by 8 will give you 1 by 4. So KL squared divided by 1L is there. That L and this one will get cancelled. You have KL by 4. So your A naught will be KL by 4. So we have found out now A naught. Now let us calculate AN. Okay. So AN is given by this expression, Fourier expression. AN is given as 2 by L, 0 to L, f of x cos n pi x by L dx. So which is equal to your 2 by L. Okay, 0 to L, you have to substitute 0 to L by 2 for the first limit. See here as per the problem. Then we will have to substitute the second one, L by 2 to plus L, k L minus x cos n pi x by L dx. Okay. So just this is, you will have to go only with the Bernoulli's formula. We have already seen the Bernoulli's formula. U dv equals U v1 minus U prime v2. Here U is nothing but differentiation, V is nothing but integration. So you will have to follow only Bernoulli's formula. And this will be your assignment and you will get the answer exactly like this. Okay. So your AN, we have found out now AN, which is nothing but 2KL divided by n squared pi squared 2 cos n pi by 2 minus 2 cos n pi by minus 1. So we have found out now AN. You substitute in this expression. So A naught is given by KL by 4. We have already found out plus 2KL by n squared pi squared. So n squared, I have written 1 by n squared here, 2KL by pi squared, other terms and all I have written here. This is already, it's there in the cos term. Okay, so this is there. So again we can simplify and this will be your Fourier series. So how to simplify? You substitute now n equals, first we will substitute n equals 2. Okay, suppose if I substitute n equals 1, what will be the answer? Cos pi by 2. Cos pi by 2 is 0. Okay. So we will not get the value. So n equal to 2. So you have 1 by 2 square. Okay. If n equal to 2, 2 will get cancelled. Correct? Your 2 will get cancelled. You have cos pi. Cos pi is minus 1. So you have minus 2. Okay. Minus 2. What about this one? Here. Cos n pi, n equals 2, cos 2 pi. What is cos 2 pi? Cos 2 pi is 1. Cos 2 pi. Cos 0 is 1. Okay, cos 2 pi also 1. So we have minus 1. Here you have minus 1. So that will become minus 2. Okay, minus 2. Already we have 2. Correct. So 2 minus 2, that will give us 0 here. Correct. So we have 1 by 2 squared. The remaining term we have already cos n pi. Cos pi is, we have 2. So we have cos n pi 2, we have substituted 2. So we have cos 2 n pi x by L. Is it okay? You will substitute n equals 2 here. These 2 and these 2 will get cancelled. Correct? We have cos pi. Cos pi is minus 1. So here minus 2. The answer is minus 2. And this is 1. So minus 1, minus 1. So this becomes minus 1, minus 1, again minus 2. Correct? Minus 2. And this will be already minus 2. So that becomes minus 4. So remember, this is 1. Okay, so minus 1. Minus 1, minus 1, minus 2 will give us minus 4. So minus 4, you pull it out, that will give me 8. See, 8kl by pi square. Plus is there, minus is there. So already they have written minus. So 1 by n equals 2. So 1 by 2 squared. Here cos 2 pi x by L. See, cos 2 pi x. Is it okay? So remaining term n equals 3, that will give you the next n equal to 4, n equal to 3. Only for the even numbers it will work out. Okay. So this is your Fourier expansion for the required function. Now if the function f of x even periodic function with the period between the limits x lies between minus L plus L, and this is given by this. Even while f of x is, this is given by, this is for odd and this is for even. The Fourier series expansion of even function is given by this expression. A0 is given by this between the interval 0 and L. An is given by this. Your Bn equal to 0. Okay, similarly for this is for the odd function. Your A0 and An will become 0 and Bn alone exists. Let us solve another problem. Find the Fourier series of f of x equal to x squared plus x. Your x lies between minus pi and plus pi. So this is again minus pi and plus pi. So we have not changed the interval. Okay, this is the origin. Okay, because x lies between minus pi and plus pi. So original Fourier series is given by this. Where f of x equal to 1 by 2 a0 an cos n pi x summation over n equal to infinity bn sin nx. Okay, this is the origin Fourier series. A0 is given by this expression. Here f of x is given as x squared plus x. So x squared plus x. So integration, that will give you x cube by 3 plus x squared by 2 with between the limits minus pi and plus pi. Now you have to substitute the upper limit. Okay, so that will give me pi cube by 3. Is it okay? Substituting the lower limit will give me pi cube by 3. Okay, now first this one will substitute. So pi squared by 2. Now substitute the lower limit will give me minus pi to the power 3 by 3. This is your minus, so minus pi cube, minus minus plus. Is it okay? Minus minus plus. And here it is minus, so this will become plus. So this is your minus pi squared. This minus pi squared by 2, this plus pi by squared 2 will get cancelled. Here it is minus becomes plus. So your plus pi cube by 3, here already pi cube by 3, so 2 pi cube by 3. Is it okay? So we have substituted the upper limit first, that will give us pi cube by 3 plus pi squared by 2. Substituting the lower limit will give you minus pi to the power 3, which is nothing but minus pi cube. Minus minus plus. This one and this one add, you will get 2 by 2. Other terms will get cancelled. So we have found out now an, correct? A0. So let us calculate an. An is given by this expression. Your f of x is given as x squared plus x cos nx dx. And this is your Bernoulli's formula as we discussed just now. So u v dx equal to u v1 minus u prime v2 plus u double prime v3. And here u is given as this. So you have to differentiate 2x plus 1. Again you have to differentiate 2. When you are going to differentiate again u triple 3, answer is 0. Answer is 0. So we can't go other than 3 terms. It means only 3 terms alone exist. See here, only 3 terms alone exist. And what are v? Your v is nothing but your cos nx. See here, cos nx. And as I said earlier, one is we'll have to integrate and another one is we'll have to differentiate. So v equals cos nx. So v1 will be v dx. Instead of v, you substitute cos nx here. Integration that will give sin nx by n. So v2 becomes v1 dx. v1 is here. So v1 is here, sin nx by n dx. So on integration that will give minus cos nx by n square. Now v3 equals v2 dx equal to integration of minus v2. This is your v2 cos nx by n square dx. So on integration that will give you minus sin nx by n cube. Okay. So now you have to multiply this with this with this, and this with this. Only then you can satisfy your Bernoulli's formula. See here, u multiplied by v1. U is here, v1 is here, u prime is here, v2 is here, and u double prime is here, your v3 is here. So now we will have to substitute. So I have substituted now. According to the formula, according to the Bernoulli's formula, I have substituted now. Okay. Now let us substitute the upper limit. The limit goes from minus pi to plus pi. So first we will substitute now pi. Sin n pi divided by n. Sin pi is sin n pi 0. So this becomes 0. So answer is 0. For the first time we are going to substitute sin pi, the answer is 0. Suppose we are going to substitute the lower limit, sin minus pi, that will become minus sin pi, again this is 0. Okay, substituting the upper limit and lower limit, that will become 0. Sin pi is 0. Sin minus pi is minus sin pi, that also will become 0. So 0. What is the last term? Last term also the similar argument, so that will become 0. Now look at the second term. First we will go with minus sign, that will give plus. So 2x plus 1 cos nx divided by n square. Now substitute the upper limit first. When I am going to substitute, that will give us cos n pi. We have already substituted, no need to write here. N pi, cos n pi divided by n square. And x, instead of x we will have to substitute pi, so this becomes 2 pi plus 1 cos n pi by n square. Substituting the lower limit, so minus, here you will have to substitute minus pi, see here. So this becomes minus 2 pi plus 1 cos minus pi divided by n square, correct? Cos n minus pi. Cos of minus theta equal to plus cos theta. So you have cos n pi. Is it okay? Cos of minus theta equal to plus cos theta. So you have cos n of minus pi equal to plus cos n pi by n square. Cos n pi, that can be expanded minus n to the power n. Cos n pi that can be replaced with minus 1 to the power n. We have already seen earlier. Okay, so 2n plus 1 minus 1 to the power n by n square. We can pull common term out. Divided by your n square also we can pull it out. So n square, common term out. Remaining term will be 2 pi plus 1. Here it is 1 minus 2 pi. See, 1 minus 2 pi. So this becomes 1 will get cancelled. We have 4 pi. So we have 4 pi. This pi and that pi will get cancelled. 4 multiplied by minus 1 to the power n divided by n squared. So that is your AL. Okay. So now we will go for BN. Again using Bernoulli's formula. So Bn is given as 1 by pi minus pi to plus pi f of x sin nx dx. So 1 by pi minus pi to plus pi x squared. Instead of f of x, you have to substitute x squared plus x sin nx dx. Okay. Now using Bernoulli's formula. So Bernoulli's formula just now we have seen. So this is your u, x squared plus x, u. This is u prime with a minus sign. This is u double prime. You have to differentiate all u's here. Very simple. So x squared plus x, on differentiation that will give you 2x plus 1. On differentiation of u that will give you 2. And this is for the integration. Your v is here. v1 is integration. You have to integrate this one and put it here. You have to integrate this one and write it here. Is it okay? So v1, v2, v3. So on integration that will give minus cos nx by n. On integration that will give you minus sin x, already 1 is there. So 1 more n, so n square. Okay. On integration that will give you minus, so that will become plus, so cos nx divided by, already n squared is there. So you have to substitute 1 more n, so n cube. Is it okay? Now As usual, the argument goes like this. We have to substitute upper limit and lower limit. The second term will go off. Just now we have seen. We will go for the first term now. First term is I have pulled minus sign out. So that will become, substituting the upper limit will give you pi square plus pi divided by n. Correct? Instead of cos nx, you will have to write minus 1 to the power n. Okay. Now substituting the lower limit. Substituting the lower limit will give you pi squared. Okay, pi squared. See this pi squared. And one more pi is there. So minus pi. And that will give me, and this term will go off. Only we have only this term alone. So substituting the upper limit will give you, this. So pi squared minus pi by n minus 1 to the power, we will have minus 1 to the power n. So there is a mistake here. So we have, there's a mistake here. Okay. So on simplifying, minus 1 to the power n, you pull it out. So that will give me minus 1 to the power n divided by pi n. So we have now minus pi squared minus pi plus pi squared minus pi, and this one pi squared will get cancelled. We have minus 2 pi, this pi will get cancelled. We have minus 2 minus 1 to the power n by n. So this is expression for your Bn. Okay. Okay, this is the expression for your Bn. And of course, when you are going to substitute pi squared plus pi, when you are going to substitute cos pi, you just substitute here cos n pi. So that becomes cos pi. Suppose n equal to 1. So this becomes cos n pi, and you are substituting the lower element will give you minus cos n pi. See here, I repeat, cos n pi, substitute the upper limit first, cos n pi. Now substitute the lower limit, that will give you cos n minus pi. One minus is there already. Okay, cos n pi is nothing but, minus n pi is nothing but plus. So that cos n pi minus cos n pi will cancel. So we have, this becomes 0. This becomes 0. This term alone exists. Is it okay? This term alone exists. This will become 0. This also will become 0. This term alone exists. You will have to substitute the upper limit first, lower limit second, and simplify. You will get the answer as Bn. Okay. So now we have substituted A. We have calculated A0, An, Bn. Substitute in the Fourier series. That will give you An, Bn. So your A0 is given 2 pi cube by 3 plus your An is given by this expression, and your Bn is given by this expression. Okay.